acute responses. Now it's time for the chronic responses to cold stress. So here are the objectives. So we're going to talk about Bergman and Allen's rule and then these three different processes. So there's been a lot of zoological studies just looking at how animals as well as humans survive in the cold. And there are a couple things that we found out. Sorry about that. So the first one is with Bergman's rule. And what he found is that people that live in cold environments have a large body mass. And so what that means is that for their surface area to mass, they have a very low ratio. Okay. And so what we mean by that is that they're just kind of short, stocky people. A good example of this are like the native Alaskans. They're generally not very tall. They're kind of stocky, I guess is the best way to put it. And what this does is this makes it easier for them to hold on to their heat. And then a guy named Allen came along, or a person, I actually don't know if it's a man or a woman, but there was a person named Allen came up with the rule that's kind of the opposite. So people that live in warm environments are normally tall and lanky. They have long appendages. So they actually have a high surface area to mass ratio. And this increased surface area makes it easy for them to dissipate heat. Okay, and we can actually see this. There are some native tribes in Africa that have people these tribes in Africa have they're unusually tall compared to others, and this allows them to do better in the heat. All right, so we're going to look specifically at a couple animals just to give you an idea here. So you've got the Arctic fox. It's a small animal, but small animals generally struggle in the cold because, like it says here, they actually have a high surface area to volume ratio. Okay, they kind of go against Allen and Bergman's rule there. But they're a little bit different because they're not humans. Humans, we don't have a lot of hair or fur, relatively speaking, but animals like the Arctic fox, they do. And so this fur insulates them from the cold, it insulates them from the wind, and it helps keep an insulative or a warm layer of air around their body to help keep that heat inside. Okay. Then you've also got emperor penguins, and you may or may not have seen the movie March of the Penguins, where you get the penguins and they're living in conditions that are like this, but probably, or it's worse to experience than to picture. And there's thousands of these birds, and they make this giant circle. And this, if you haven't seen the movie, basically what happens is this group of penguins is constantly circling, and the penguins on the outside are constantly moving towards the inside, and the ones on the inside are moving their way outside. Okay, so basically they're taking turns, and so the job of the ones on the outside is to kind of block the wind and all that for the ones that are inside. And so normally these birds have a temperature around 38 degrees Celsius, but it gets so cold there that if they were to rely on what they can do individually, they wouldn't make it. But when they huddle together, and these are thousands and thousands of birds, they generate enough heat, they become insulated enough that they can maintain their heat. Because basically what they're doing is they're minimizing their surface area relative to their mass. Okay? If you haven't seen the movie, I would actually encourage you to go see it. It's quite fascinating. Okay, so this leads to acclimatization when it comes to the cold. So in order to be acclimatized, we have to experience chronic or repeated cold stress. And so if we're losing heat, the first thing you have to do is decide, are we losing heat? And based on this question, if the answer is no, then we're experiencing what we call cold habituation. So cold habituation, just in general, habituation is where a response is reduced, or like it says here, a dampened. Okay, basically you kind of become used to it and you're able to handle this better. So when it comes to cold habituation, there's two components. One, you don't shiver as much, and two, you don't have as much vasoconstriction. Basically, your body's adapting to this cold stress and it's able to handle it. Okay, so however, if you're losing body heat, then you need to be able to make up for that lost body heat. And so is this due to metabolic heat production? Yes or no? If the answer is yes, then we call this metabolic acclimatization. And again, there's two parts to this one. And so the first one is what we call enhanced shivering thermogenesis. And so what that means is we're better at generating heat, thermogenesis, or creating heat, by shivering. And we do this via muscle contractions, right? Shivering is just involuntary muscle contractions. They don't provide any useful work, but they do provide heat. And then it's possible that we also experience what's called enhanced non-shivering thermogenesis. Okay, and this is from something called brown fat. Now, most adults don't have brown fat. Babies are actually born with brown fat. And brown fat goes through things work. It actually is more similar to muscle, but heat can be released from this fat. Okay, and what happens is we don't actually rely on carbs. We focus on lipids. Okay, or using fat utilization. Okay, and that allows us to use carbohydrates when we really need them. And then next we have insulative acclimatization. So if I can't generate enough heat to defend body temperature, we go to insulative acclimatization. Two components to this. So we have increased vasoconstriction, and we end up having an increased core to skin gradient. Okay, that sounds bad because if we've got an increased gradient, that means we're going to lose heat. However, we don't lose that excess heat because of the vasoconstriction. So the vasoconstriction causes the gradient, but because of the gradient, even though we've got this gradient, the vasoconstriction prevents us from losing excess heat. And so we're going to end there. In class, we'll talk a little bit more about each of these things in detail.